All right, I'm going to just do the 2 polyatomic ions real quick because I know in some of the classes we didn't really get to them, and I want to make sure you know how to do it. You start the same way. Nitrogen has 1 valence electron, 5 valence electrons. Sorry, hydrogen has 1. There's 4 hydrogens. But then the difference with the polyatomic ion is that charge. We have to take that charge into account when adding up how many electrons to use. If it has a positive charge, remember it's because it lost electrons. So I'm going to subtract 1 from my total. No one particular thing lost the electron. I'm just going to subtract 1 from the total and use 8. Nitrogen is going to be my central atom. And I'm going to start by single bonding hydrogens all the way around because there's 4 hydrogens. And remember, a line is the same thing as 2 dots. So sometimes it's just a little bit easier to see the line than the 2 dots. So I used 8 electrons. The next thing I have to check is if my octet is fulfilled. And everybody's octet is fulfilled, so I'm done. Now with a polyatomic ion, you do have to put it in brackets with the charge on the outside to show that it is the polyatomic ion. If you don't have those brackets with the charge on the outside, then one is going to assume that it's not an ion and that you don't have a correct Lewis structure. So when we're doing phosphate, phosphorus has 5 valence, oxygen has 6, there's 4 oxygens, and then the -3 charge means I add 3 to my total. I have 32 total. Phosphorus is my central atom, single bond to all 4 oxygens. So that's 8 electrons. I have to use 32. So you end up just putting lone pairs around all the oxygens. And as you put lone pairs around all the oxygens, that adds up to a total of 32 electrons. And then, of course, check your octet. And everybody's octet is fulfilled. To finish off this polyatomic ion, put it in brackets with the charge on the outside. Now we need to talk about something called a resonance structure. A resonance structure is when a molecule has more than one valid Lewis structure. On the assignment that you were supposed to do, you had both nitrate and nitrite, and they both show resonance. So let's look at what resonance looks like. If I have ozone, which is O3, start out the same way, right? We have 6 valence electrons, there are 3 oxygens, so I can use 18. These 3 O's are just going to be bonded in a line. So always start with single bonds. So it's 4, put the rest around the outside. So 4, 8, 10, 12, 14, 16, 18. It doesn't really matter how you put them. You're going to end up at the same spot, so it doesn't really matter. So, let me erase. Hold on. So it doesn't matter where, but I just want to show you this idea of resonance. So actually I'm going to start like that. 2, 4, 6, 8, 10, 12, 14, 16, 18. I didn't have enough anyway. All right, 18. The center oxygen, this oxygen right here, does not have an octet. So when we are in that situation, we always erase a lone pair and make it a bonding pair. The question becomes, do I erase it from this oxygen and make a bond here? Or do I erase it from this oxygen and make a bond there? And the answer actually is, it doesn't matter. And this is what resonance is. When I can erase this lone pair right here and make it a bond and do it on that side, or start out how it looked before. That shouldn't go there. Oh, yes, it should. So that's how it started out before. I could also erase this lone pair and make it a bond on this side. So that is resonance. Both structures are equal, and in fact, both are correct. The way you show that something has resonance is you draw all the structures. Yes, you have to draw multiple structures. And then you actually, I didn't leave a lot of space for this, but you would draw a double-sided arrow between the structures to show, yes, both of these structures do exist. For carbonate, you will end up with 3 resonance structures, because I will have carbon, oxygen, 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 and then 2, 4, 6. I didn't add up the total. 4, 6 times 3, 18 plus 4 is going to be 24 total. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that carbon needs another pair. Which oxygen am I going to take it from? Turns out it doesn't matter. So one resonance structure of carbonate looks like that. And of course, yes, it has to be in brackets. The other resonance structure is going to have the other oxygen with the double bond. And then a third resonance structure, which I'll smoosh in here, would have the double bond on the bottom and then single bonds on the side. So it kind of look like that. So that one has 3 resonance structures. Yes, you have to draw all 3. Only for today, only when you do this assignment. All right, exceptions to the octet. So yesterday we talked about how everything is trying to fulfill the octet rule. Everything is trying to get to a stable 8. We had one exception already, which was hydrogen. Hydrogen can only have 2 because of its 1s orbital. Turns out boron will also typically form a suboctet. Boron, instead of having an octet, will have 6 electrons around it. So when I have BH3, boron has 3 valence, hydrogen has 1, there are 3 hydrogens. It's a total of 6 electrons. Boron's my central atom. I single bond it to all the hydrogens, and then I'm done. Because first of all, I've used all 6 electrons, and secondly, that's what boron wants. So if I gave you something like BF3, for example, boron has 3, fluorine has 7 times 3, you're going to use 24 electrons. Boron's in the middle, 1, 2, 3, and then that's 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then you're done because boron only wants 6 electrons around it. Typically what's going to happen, I know you're like, wait, why? Typically what's going to happen is something like boron is going to bond with something like ammonia, which is NH3, and has this lone pair up here. And so then it will end up sharing those electrons right there. But boron itself really is good with 6. So boron and hydrogen are both going to get a suboctet. Expanded octets are going to be when the central atom contains more than 8 valence electrons. The only expanded octets I'm going to give you are phosphorus and sulfur. And you're going to know it's an expanded octet when, again, there's more than 4 things bonded to the central atom. Phosphorus can actually have 10 electrons around it, and sulfur can have 12. Only, again, when there is more than 4 things bonded to the central atom here. So like if it's PCl4, you don't give phosphorus 10. But if it's PCl5, you kind of have to. Phosphorus has 5 valence, chlorine has 7, there's 5 chlorine, so we're going to have a total of 40 electrons. Phosphorus is my central atom, and then we single bond all the chlorines around it. So that's obviously 10. To get up to 40, you put lone pairs around all the chlorines, and when you do that, you see, yes, you have in fact used 40 electrons. So that is an expanded octet, and hopefully that will be enough instruction on that, and you can do the posted assignment. Please email me if you guys have any questions.